In this problem, we have to find the force in the coupling seal between the two cars. Now you see the car A has a weight of 20 pounds, while the car B has a weight of 30 pounds. Now you see these two weights are acting vertically downward, and you see both these cars are moving in the negative x direction, while we have a coefficient of the kinetic friction between the wheel A and the track, which is 0.5. So it is acting towards the positive x direction, while the wheels of the car B are free to roll. So you see, this is the free body diagram of the car A, and this is the free body diagram of both the cars. And if we separate car A from the car B, so with the car A, we have a kinetic friction. And perpendicular to this, we have a normal force. We have the weight of the car A, and also we have tension force between these two cars. And in case of the angle, we can draw like this. So it is with the y-axis. So as you see in the car A, in the vertical direction, we have a normal force, which is acting vertically upward. And we have the weight that is 20,000 pounds. And we have angle 5 degree, while the angle is with y-axis, so we use cos component. So the normal force is about 19,923.89 pounds. And in the case of the horizontal forces, since the car is moving, so we use the Newton's second law of motion, which is F is equal to ma. So this is the force which is equal to mass multiplied acceleration. So you see, we have a kinetic friction that is acting in the positive x direction, and perpendicular to this, we have the normal force. So we multiply these two values, so we get 0.5 multiply 19,923.89. And you see in the car A, the tension force is acting in the negative direction, so we have negative d, and for the weight, we have 20,000. And in case of horizontal direction, we have sine component at angle 5 degree. And you see, for the mass, we know that weight is equal to mass multiplied force of gravity. So for mass, we have the weight that is 20,000 over the force of gravity. You see, in case of pounds, we write 32.2, not 9.81. So you see, we can find tension through this equation, but we are not given the value of acceleration. So we have to find the value of acceleration. For this, we can take both these cars. So with the car B, we have the weight and the tension force. So if we see the free body diagram, then in the horizontal direction, we have again the kinetic friction and normal force that is perpendicular to it. And we have a collective weight that is about 50 pounds, and we have sine 5 degree. And also we have collective weight and over the force of gravity that is 32.2 multiply acceleration. So we get acceleration, which is about 3.61 feet per second square. So we can assume that this is our first equation. So we can put the value of A in this equation. So the equation becomes like this. So now we can find the tension, which is 5.98 kilopounds.